Hello everyone. In this video, I will be discussing about Grob fragmentation. So Grob fragmentation is an elimination reaction, is an elimination reaction that breaks a neutral aliphatic species into three fragments. One of them will be a positive fragment, positive species, one neutral, and one anionic. Okay. So this fragmentation, this requires an electron push and pull. The fragmentation requires an electron push and an electron pull. That means in the aliphatic chain, in one side there should be a group which will push the electron, and in the other side of the aliphatic chain there must be a group that can pull the electron, right? So mechanism is like that. We have a X group, so this is the electron donating group, this is the electron push from this side, and here electron pull. Okay, that means here it will go like this. So this one will push the electron, this bond will get shifted, and this will leave. That means we will get a positive species, a neutral species, and an anionic species. So we are getting three fragments. Okay. Let's take an example. I have a system like this. So you have a OH group. So this is both a symmetrical group, right? In both the sides, we have a OH group. But if we add over here acid, if we add one equivalent of acid, so what will happen? So if you add one equivalent of acid, one of the OH will get protonated. That means a OH2 group. Now you can see that here we have a lone pair push in this side. In this side we have a lone pair push, and in this side we have a leaving group. We have a leaving group pull. That means the lone pair will push over here, this bond will get shifted over here, and this leaving group will leave. So what we are getting this one as the product. Here we are having OH plus. So we end up with this species, right? So this is the product. Let's take another example. Let's take another example. If we have system like this, if we have a system like this, we have a keto group, right? So we are adding a first base. So what this base will do? This base will directly attack here. So we are getting this OMS. Here we are getting O minus and OH, right? Now this side becomes a negative charge push. Let's see, this is a negative charge push, and here we have OMS group. It is a leaving group. OMS is a leaving group, so it is a leaving group pull, right? So this will come over here, this bond will shift, and this OMS will leave. So we are ending up with this product. Okay, So this is the product of this reaction. Okay. So next we'll see this fragmentation can be controlled by stereochemistry. Fragmentation can be controlled by stereochemistry. Okay. So if you have a system like this, we have a OTS group above, and in the third position we have a tertiary amine group is also above. So this is our cis product. So let's draw the shear conformation. So this is the OTS group, and here we have a NME2 group. So we can see that here we have a lone pair push. We have a lone pair push. Here we have a leaving group pull. And this leaving group, this leaving group bond, and this bond is anti-periplanar. Okay. Anti-periplanar. This must be anti-periplanar. So this will come here, it will push, this bond will go over here, and this will leave over here. So we'll end up with here NME2 plus, and we're getting a bond. If we treat it with water, we'll get basically CH. So this is the product of this reaction. So now if you take the trans isomer, here we have a cis isomer. If we take a trans isomer, then what will happen? If we take a trans isomer, let's say we're taking a trans isomer, here we have the OTS group, and here above the plane we have the NME2 group. So if we draw the shear conformation, so here NME2 will be like this, and here OTS will be like this. Okay. So what happens? These bonds are not anti-periplanar. These bonds are not anti-periplanar. So fragmentation, so it cannot take part in this type of fragmentation, will not take place. So what will happen? So since OTS is a living group, and since we have a anti-periplanar hydrogen over here, so the base can abstract this hydrogen, will end up with two products. So if this hydrogen will get abstracted, so we'll end up with, so this is the double bond, 1, 2. So second position, we have a NME2. And if this one gets abstracted, so we will get this product NME2. Okay. So if you look at the other conformer, if you flip this system, what will happen? If you flip it, so basically what will happen if you flip the system, we'll get an OTS over here and NME2 over here. Now we can see that these two bonds are periplanar, but over here we have a 1,3 diaxial interaction. So we have a 1,3 diaxial interaction. Also, we have an anti-periplanar double bond. So since this conformer is not so favored conformer, so what will happen? The reaction will take place, but the yield will be less. So it will end up with some aldehyde, but the yield is very low. That is around 10% yield will get, because this conformer is not so much stable. So we'll get the product, but the yield is very less. So this is all for this video, and thanks for watching.